everyone. This is Kestrel Raptorial. I'm here to talk about, as I promised, what happened, what came of that night. I went to the talk about the science of Jurassic Park. Kitty cat. So, I'm going to be using a lot of notes. And I'm going to talk a lot. So, as I said, I attended a talk on the science of Jurassic Park that took place on the evening of November 10th, 2016, which turned out to be a little different than I expected. I thought it was an actual and only a collaborative discussion about the science involved in the movies. What it really was a theater showing of the original Jurassic Park movie, which was awesome, but again, not what I was expecting. And then a question and answer session with one of our local paleontologists afterwards. The movie. What can I say about the movie? When I was very little, I was a Superman fan. I watched all the original 4 movies, yes, even 3 and 4, which I now admit are hilariously bad, but come on. I hit my Superman fan peak at 5 years old, okay? Actually, I'm a little surprised a 5-year-old was so into those movies. There's a lot of adult yada yada speech and not nearly as much action as I thought I'd remembered. Oh well. Jurassic Park was my next phase. When the movie came out in 1993, I was 8 years old. I heard about Jurassic Park as all little boys and a lot of little girls. I was into dinosaurs. I liked dinosaurs. I knew a little bit about them. So I wanted to go see it. I think it was rated PG-13 at the time, and let's see, in the early 90s, the PG-13 rating, I guess, meant a little bit more than it does today, although by no means was an 8-year-old not able to go see it. I wanted to. I begged my parents to go see it. And they were afraid at first that I would be scared by it. I would be scared by the dinosaurs. But they eventually did take me. And as it turns out, they need not have worried. I was cheering for the dinosaurs the entire time. I love them. Especially the predators. The instant I saw the velociraptors, I fell head over heels for them. Squee! I'll tell you, if there's any truth at all to the concept of love at first sight, that was my experience of it. Seeing a velociraptor for the first time. Instantly became my totem animal, along with the one that inspired my online name, the American Kestrel. My comfort object as a child, which I'm still holding now, is a Velociraptor plushie. I collected literal packs of toy raptors. I drew raptors. I wanted to be eaten by raptors. I built and still wield. I showed you a little bit of this. My trading card game decks revolve around raptors. And in Magic the Gathering, it's the Shivan Ridgetop and Frenetic Raptor, along with a lot of flying creatures, eagles and kestrels and sage owls, and I'll bring that deck out sometime. And I practice raptor screeches. I could probably do a better one. I am a velociraptor groupie. Okay, so maybe my parents did have reason to worry, but not quite the reason they think, and it's too late now. Of course, the original Jurassic Park was awesome. It was absolutely groundbreaking for its time, and still holds up amazingly well today. All of the scientific and ethical issues the characters talk about are still very much relevant to cloning animals today, to the extent that we've been able to do it, which is still not that far. There's always research going into it. There's research on reverse engineering birds into dinosaur-like creatures. Very interesting project. Haven't looked at the updates in a while, but and I touch on that a little bit in my video titled Pokemon Yu-Gi-Oh! Or Yu-Gi-Oh! Then Pokemon, not sure which. At Jurassic Park. Near the end, I talk a little about why cloning dinosaurs, the way that is done in the movie, meaning extracting dinosaur blood DNA from ancient mosquitoes, while the concept, the idea, sounds plausible, is actually impractical and almost impossible. The illusion of control, which is an underlying theme and message in the movie, and even chaos theory, which is not really what the story is about, is still handled well. The lawyer, of course, while far from the most obnoxious or destructive lawyer I've ever seen, that label would go to family court and divorce lawyers who have no idea of the destruction they wreak upon children's lives. You still want to jump into the movie just to scream, "Shut up!" at this lawyer. And of course, when he is the first to get eaten, barring the loading worker in the very beginning, everyone cheers. Figures he'd also be the one to abandon the children. That part is particularly realistic. One problem I didn't recognize for quite some time was that in the beginning, Alan Grant and his team are digging in Montana. They're excavating a velociraptor skeleton. And in the movie's novelization, there is also a Tyrannosaurus, which was a large prey animal. I think it was a hadrosaur. And in fact, the episode of Jurassic Fight Club, the episode titled Gang Killers, which I will talk about in another video, depicts a battle between Tyrannosaurus and a pack of raptors. The raptors in that show are identified as Deinonychus, which in fact, when Deinonychus was first found, it was considered to be a species of velociraptor before it was given its own genus name. So the movie isn't really that wrong in calling its dromaeosaurs, which were based on Deinonychus. Were they based on Utahraptor? I think Utahraptor was bigger still. So I think they were based on Deinonychus. So calling Deinonychus, or even Utahraptor, Velociraptor, all of them being of different genera is all speculation anyway. They are very closely related. In Montana, and I think in the original novel they were digging in snake water. Well, the earth in that region is sandstone and shale, which are tough to dig through, and paleontologists working in that location often have to use chisels and hammers to cut around the skeleton and then air or truck lift the whole rock slab out of the ground to be carefully chipped away at the lab. There's not a lot of soft soil or sand that you can just brush off of the fossils out there. Now, Mongolia, which is also a rich dinosaur fossil site and home to the real Velociraptor mongoliensis, is very sandy earth, and in the Gobi Desert you can use brushes. One of the best scenes in the movie, and sometimes recognized as just a great scene in film overall, is the lunch scene, the Chilean sea bass, where John Hammond is talking to the team that they've brought along, and unfortunately the lawyer too. But anyway, I've been thinking a lot about that conversation. And let's start with Ian Malcolm. Jeff Goldblum, the actor. He says, after the group has already seen the Brachiosaurus, the Parasaurolophus, the herd from a distance across the lake, and there were also other Brachiosaurs. They know there's a T-Rex. Hammond did tell them that we have a T-Rex, but they haven't encountered it yet at this point. And the Velociraptor feeding, although I'm not sure if they could ever actually see the raptors inside the pen. They had this shocked, grossed out look in their eyes when the raptors were tearing the cow apart, but I couldn't tell that they actually saw what was going on. They just saw the blood flying everywhere. Which it'd be cool if we could have actually seen even more of that. Jurassic Park, Higurashi. So that would be awesome. And that pen looked really small for holding such active predators of their size. No wonder they were trying to break out so often. So, okay. So, at the lunch, Malcolm says the lack of humility before nature that's being displayed here staggers me. And he's absolutely right. In fact, that itself could be a subtitle of the entire movie. The idea that the park has any real control over creatures like this is a kind of human elevation and arrogance that technology can overcome nature. Well, the scientific method and the development of advanced technology can be used to understand nature, but it will never break through the laws of physics. It may uncover new ones and lead to a better understanding, but it isn't going to change the laws themselves, nor is it going to change how weather and climate work. We can affect it, and again, whole nother video, I'll address the global warming stuff. But we're not going to be changing how the Earth's rotation and distribution of heat and water leads to various wind and rainfall patterns. again, yes, we can affect it. Yes, we can. Our activity can redistribute it a little bit, but how the cycles themselves interact with each other and work, we're not going to be changing. We can't stop a volcano from erupting, let alone a supervolcano. And we're not going to be changing the nature of predatory or prey animals. We can domesticate some and breed them to be more human-friendly. But hey, we haven't changed cat nature that much at all, for example. And dinosaurs, these are animals that kept mammal evolution suppressed during their entire 150 million year reign on Earth. Dinosaurs were powerful, intense creatures, and I do think that as intelligent as humans are, before them, we barely cling to survival on the fringes of their territories. Now, when John Hammond gives the example of gives Malcolm the example of if his team had cloned a flock of condors on this island, Malcolm wouldn't have any complaints. And then Malcolm responds with, this is not some species that was obliterated by deforestation or the building of a dam. Dinosaurs had their shot, and nature selected them for extinction. Well, that's not quite how natural selection works. Nature is not a sentient force. Birdie clock. I have a piece I wrote today about how the dinosaurs actually became extinct. Let me track that down. Oh, I know where it is. Yeah, because this will help me. I might as well read it because it's not directly explored in the movie how dinosaurs became extinct, but Malcolm did bring that misunderstanding up, so I might as well. Okay. So someone asks me if the comet, he's referring to the KT asteroid, which may have been a comet, impossible to tell which it was, and doesn't really matter which it was random. How could nature have selected dinosaurs for extinction? Okay, so here's my reply. That was a misstatement or misunderstanding. I don't know if Malcolm in fact understands natural selection or not, or if that was just a miswording. So that was a misstatement of how natural selection actually works. Nature is not a sentient force, so it didn't choose anything for extinction. The comet or asteroid was a random catastrophe, and it happened to strike when the dinosaurs were already highly stressed due to the Earth going through a height of volcanic activity in the late Cretaceous. The land became more arid, and dinosaurs had recently, throughout the Cretaceous and most near the end, which would eventually be their downfall, produced a lot of large resource-guzzling species to try and outcompete each other. And in the late Cretaceous, you do see a lot of dinosaur genera with their largest species. Some of the largest hadrosaurs, the largest horned dinosaurs, and of course you got Tyrannosaurus rex. The largest sauropods had lived during the Jurassic. And so the largest of them had disappeared. That was that was a much earlier age of gigantism. This one was going to kind of proved to be the death knell. Which meant that the environmental factors kept stacking against the dinosaurs, the absolute worst time for that one last disaster to come. The impact, meaning the KT asteroid, was the point of no return for the dinosaurs, and it just happened like that. It was a random last event. The dinosaurs had had a reign of 150 million years, and the birds are still with us. Actually, an amazing success story for any group of animals. So that's the... even that is an abbreviated answer, but that is the overall truth of why the dinosaurs eventually became extinct. Natural selection is not a sentient force. Gotta bring up the right file again. Okay. Oh, so I was going to go through the entire correction of that argument in a whole another video, but I kind of just did. I can elaborate on it again if anyone wishes. Anyway, he is correct in pointing out that cloning the dinosaurs is a very different situation than reconstructing a species destroyed by human activity. Then he gives a very rapey portrayal of scientific discovery, which is neither exactly right nor wrong, but... Okay, that sounded dark. I'll address that some other time if I have to. Another good point is when Ellie Sattler raises, how can you know anything about an extinct ecosystem? Which, as this area is my scientific specialty, is a very good question. There are some very ingenious and detailed ways of deducing and reconstructing, at least conceptually and artistically, what a prehistoric ecosystem may have been like. Now, of course, back in 1993, when this movie came out, a lot of these methods were still in their infancy. But there are some very interesting things paleontologists, paleobotanists, and paleoecologists can do. Still, her point is a valid one. Then Alan Grant says, I don't want to jump to any conclusions, but look. Dinosaurs and man. Two species separated by 65 million years of evolution have suddenly been thrown back into the mix together. How could we possibly have the slightest idea of what to expect? It's funny that they keep referring to dinosaurs as a single species. There are around 6,000 species of dinosaurs named as of now. Now, many of those may well be juvenile or reversely adult forms of other named species of specimens, fossils that they think belong to different species may be, in fact, some of them may be different life stages, but to determine that, as they're trying to do with, for example, Tyrannosaurus rex and Nanotyrannus, that takes a lot of study to even hypothesize about. So, as of now, the number is around 6,000, and that's changing all the time. Usually increasing. By the way, I know what to expect I've said it already, we'd all be barely scratching out survival on the fringes of dinosaurs' territories, which is pretty much what keeps happening to the humans in the Jurassic Park movies. They should have invited me to the island. I'd have had a field day with all the dinosaurs running wild and chasing me. I guess Isla Sorna would be better for me then. I totally want to be jumped by a raptor. That'd be awesome. Or I'd want to be one of the raptors. Even more awesome. Scooey! I think I'm going to have to do a whole series of discussions about the Jurassic Park movies. The science involved. I was wondering if I still had my copy of The Science of Jurassic Park, the book. Turns out I do. It's actually titled The Science of Jurassic Park and the Lost World. So it covers, should cover both movies. I haven't read it in a while. I am going to refer to it a little bit, though. I also have the original Michael Crichton Jurassic Park book with me. I don't have the movie novelization itself. I don't have that one. But I do have The Lost World as well. And I have Robert Becker's book, bring it. Raptor Red. This book is kind of both a story and a documentary in one. And it has quite a lot of the origin of mammal evolution in it, which is fine. It's a little bit interesting, but kind of distracting. Still a very good book. For now, let's talk about the question and answer session that took place after the showing that night. So it was a typical question and answer session that you'd see and participate in at a paleontology lecture at a museum or speaker's speech anywhere, or special showing of a movie, and the like. I brought a notebook and recorded the questions that were asked by people and the answers that were given. So, let's see, I'll track it down. With the questions about reconstructing an extinct ecosystem, the paleoecology. Turns out a couple days after, Saturday, in fact, November 12th, there was a whole series of dinosaur lectures at my Natural History Museum, and one of them was about doing exactly this. And so in another video, when I talk about what went on at that series, I will address that. Some very interesting stuff. Okay. So let's go through these questions. Number 1. In the movie, John Hammond says they had clocked the T-Rex as being able to move at 32 miles an hour. Could Tyrannosaurus Rex actually run that fast? Well, the paleontologist there, whose name was Dr. Michael Ryan, said that there really hadn't been T-Rex footprints depicting its stride found to go on, and that's kind of where he stopped. Actually, he did mention that there were ways through looking at the bones for paleontologists to make guesses. There are a number of ways of estimating a prehistoric animal's possible speed. And based on a little bit of looking around, it seems that there have been scientists constructing computer models of Tyrannosaurus leg structure, how it responded to pressure during motion, width versus length, overall strength, and have deduced from those that an adult Tyrannosaurus rex probably had a running speed of between 18 and 25 miles per hour, not 32. Now, again, this is all best guess. And that's still enough to overtake a lot of humans, especially if Tyrannosaurus manages to take them by surprise first. Number 2. Oh, this is the question I asked. Why have none of the Jurassic Park movies depicted the raptors as feathered yet? Birdie raptors are kawaii! Anime eyes sparkling whenever I see raptors. Wish I could make my ass actually do that. So I was thinking that last part, I only asked the first part out loud. Raptors are cute is one of the staple thoughts I just have each day. Why wasn't I born as a raptor back in the late Cretaceous? Oh well. So, the answer is, and I probably kind of knew this, I'm still surprised that none of the movies have done it. I was expecting at least Jurassic World to do it, and they keep kind of hinting a tiny bit at feathers. They give them like little tiny crest quills or something. It's weird. The answer was it's well, the scaled raptors are iconic of Jurassic Park. They are they're easier to merchandise. They're easier to trademark. They should have already been trademarked. I know that's the word he used. I guess they'd also be easier to construct models for. That's probably true. And the Jurassic Park movies have been going in the direction of describing the dinosaurs, claiming them to be more monsters than actual dinosaurs. Actual dinosaurs, apart from birds, being long gone, and they've just recreated monsters. In fact, in the third movie, Dr. Alan Grant directly says this. But it's pretty much been conclusively established that dromaeosaurs and even tyrannosaurs, a lot of those dinosaurs, close and closest to the ancestry of birds, were feathered. In fact, fully feathered. And in fact, the smallest, including Microraptor, even had the origins of flight feathers, probably more used for gliding than powered flight. I don't think powered flight had quite come yet. But it is strange that they haven't really made feathered raptors for the Jurassic Park movies yet. I guess for the reasons mentioned, I just keep wanting to really see them. Number 3. What's the most interesting discovery made in the last 5 to 10 years about dinosaurs? The answer was, the revelation of feathered dinosaurs has been huge. The revolution of dinosaurs actually being the ancestral group to birds came a little earlier than 5 to 10 years ago. I think that was just beginning around the time the first movie came out. So if it's the last 5 to 10 years from now, then yeah, it's the revolution of full feathers. They've even found ways of determining some actual dinosaur colors. The colors of the skin and feathers, for real. They've also found dinosaurs, some remnants of dinosaur brain tissue preserved in these very finely preserved fossils. The discoveries, or what they can do with the fossils, has only been getting more and more detailed. So that has been amazing. Number 4. Is it true that most of the dinosaurs shown in the movie, and they're just talking about the original Jurassic Park movie, just number 1, were not of the Jurassic period, but in fact lived much later? And the answer is yes. I believe there were 6 iconic dinosaurs featured in the original Jurassic Park movie, or at least the ones that liked to be, the iconic advertised species. I think there were 6 of them. Maybe there were less. Let me see if I can remember what they were. There's Velociraptor and Tyrannosaurus, of course. The Triceratops, the Brachiosaurus, Gallimimus, and I thought there was a 6th. Dilophosaurus, of course. Okay, so those 6. Okay, let's turn to the Science of Jurassic Park book. I knew I was going to use this. So this is a somewhat outdated book, but still a good read. And in here is a dinosaur time period of a lot of the, let's see if I can angle this right, a lot of the dinosaurs did live. Okay, here we go. They don't have Brachiosaurus, but they do have Apatosaurus listed in the Jurassic. Brachiosaurus would have also lived in the Jurassic. Dilophosaurus is down there too. That was an early Jurassic predator. So Brachiosaurus and Dilophosaurus did live during the Jurassic. Whereas Gallimimus, Velociraptor, Tyrannosaurus, and Triceratops. Tyrannosaurus and Triceratops are iconic of the late Cretaceous, of course. There's T-Rex, there's Triceratops, Velociraptor. And I don't think they have a Gallimimus here. So this is the Cretaceous. This is a very, very simplified time period, of course. There are much more complex ones out, but this is from the Science of Jurassic Park book. So anyway, 4 of the iconic ones lived in the Cretaceous. I don't offhand remember if Gallimimus lived during the early, middle, or late Cretaceous. I can look it up, but I don't know offhand. Velociraptor was late Cretaceous. Tyrannosaurus and Triceratops were. Yeah, that's the 4. Okay. So yeah, and of course Jurassic Park is just the park name. It doesn't mean everything's exactly from the Jurassic. Number 5. Okay, so this is about the tropical storm that hit in the movie. And of course they're in the middle of the Pacific Ocean at the same latitude as Costa Rica. They're in a tropical zone. In the right in exactly where you're going to get tropical storms. So they must hit the island a lot. And when the fences were turned off and the dinosaurs could escape, is there a possibility that any dinosaurs can swim to the mainland? Which was then simplified to, could dinosaurs swim? Yes. Based on their anatomy, it's a pretty sure thing that a lot of dinosaurs could swim. Maybe apart from the absolute heaviest. The sauropods were probably not very good open water swimmers, but a lot of the theropods would have been able to. Now this does not mean swim exceptionally well. Of course, they're nothing compared to the actual sea creatures, but swim they could. Crossing entire oceans is another story altogether. However, in the epilogue of the original Jurassic Park book, some of the dinosaurs, it seems, have actually made it to the mainland. The epilogue is pretty short. Okay, the epilogue is called San Jose. It's only about 3 pages long. And it seems some of them have entered the jungles. In the beginning, also, there's a little bit of reference to. There's a boy attacked by a creature that he calls a raptor. And this very first part is very similar, in fact, to the opening of the Lost World movie, where the little girl on the beach is attacked by the Compsognathus. So, prologue, The Bite of the Raptor, deals with this. So it even seems that some of them have already escaped and made it to the mainland. So yes, in the original story this does happen, and yes, dinosaurs could swim. Number 6. Can we clone extinct animals? And the person who asked this, I'm getting tired, who asked this, really asked more about Ice Age animals, since getting enough material to clone dinosaurs is near impossible. Unless, again, you want to reconstruct them through turning on dinosaur-like genes in birds. Which is possible. There's already experiments about that. So Ice Age animals. There is a lot of tissue a very well preserved tissue from Ice Age animals. And there are very possible projects dealing with attempts at doing so. I have not yet heard that they've seriously been attempted, but it's certainly very plausible. We do have a lot of Ice Age animal genetic material. Those animals having only died out 10 or a little bit fewer or more thousands of years ago, of course, many, many, many times more recent than the dinosaurs. So the DNA has a much greater possibility of still being intact. Yeah, it's possible. Again, I've talked a little bit about the trouble of getting any possible dinosaur DNA with DNA being so easily degraded in nature. Was that number 6? I think that was number 7. Okay. Are the strides of the dinosaurs accurate? Meaning how the dinosaurs would move in the film. Were they recreated accurately? Mostly. Very much mostly. Based on the best science they had at the time, it's been about 20 years, 23 years. So there have been a lot of updates, there have been a lot of discoveries since, but mostly, yeah, still very accurate how they moved, as best as we can tell. They did have a paleontologist as a consultant for the Jurassic Park movies, Jack Horner, who is one of the world's experts on Triceratops now. Interestingly, we never saw the Triceratops walk in the movie, but he was a consultant for dinosaur locomotion in that film. So yes, how they moved as a whole, very, very accurate, to the best of our knowledge. If dinosaurs did not disappear, what would be Earth's dominant species? Okay. This could be taken a couple different ways. Well, notebook. I just have too many books piled together. Too many notes, too many articles to read, too many... Well, I guess I haven't made any actual discoveries. I wish I had discoveries to go through, but mostly it's just reading a lot of articles and sorting through a lot of data, which is actually, and a lot of just work, which is a lot of what paleontology really is. It's what a lot of ecology really is. Reading a lot of books. Sounds a lot like school, which is also very tedious. Okay, so back to the... right, Malcolm's got me doing it. Back to what would be the dominant species had the dinosaurs not gone extinct. Which is often put as, what would have happened to mammals or to humans? Well, dinosaurs in their entire 150 million year reign, over their entire 150 million year reign, pretty successfully kept down the evolution of mammals. So, would humans have evolved had dinosaurs never gone extinct? And technically they didn't. I mean, birds are the descendants of dinosaurs. They are dinosaurs, cladistically, but we are, of course, talking about non-avian dinosaurs as a whole. No, humans probably would not have evolved. There would probably not have been the opportunity for them to. Maybe we would have all been born as dinosaurs. And we would be the dominant species, but we would be dinosaurs. There is this idea of, mostly in artwork and in models, I've seen a few pictures, this idea of a dinosaur man or dinosaur human. I can't remember who the artist or the proposer was. I haven't given it a lot of credibility, but it was based on a dinosaur called Troodon, which was closely related to the raptors, to the dromaeosaurs, and in fact was one of the dinosaurs focused on the series of lectures I went to a couple days later, Dino Fest at the museum. So I will be talking about Troodon when I get to that. The idea that dinosaurs would have eventually taken on a humanoid shape, or that the biggest brain of them were. Other people have proposed something I think is far more likely that I would go along with more, is that theropods increasing in their encephalization quotient and increasing in their brain power would have still kept mostly theropod dinosaur shape, which is bipedal, but rather than standing fully upright as humans do, they're more horizontal. They're that the length. The small head, long neck, long tail, horizontal shape, which I think is how they would have gone. I don't think they would have become humanoid in shape. And again, mammals pretty much were reduced to exactly what the humans are usually reduced to in the Jurassic Park movies, barely surviving at the edges while dinosaurs take over the ecosystem. So yeah, had the non-avian dinosaurs not gone extinct, I think they would still be the dominant creatures. Okay. Here's one. So in the Jurassic Park film, when they take the beginning of the tour, when they're watching the movie about how the dinosaurs are cloned through mosquito DNA, they watch this little cartoon character, Mr. DNA, who tells them that to complete the dinosaur genetic sequence, the Jurassic Park geneticists used the DNA of a frog, and the question was, why use amphibian DNA for the dinosaurs? Why not use a creature far closer to dinosaur ancestry, birds? And of course that would be far more logical. But it was a plot device to introduce later on in the story the whole the revelation that amphibians can sometimes change sex in a single-sex environment, or Alan Grant references West African frogs. I myself don't know a lot about West African frogs. I would not be surprised at all if quite a few amphibians had that ability, if the environment is truly stressed to the point where there's mostly only one gender around. I don't know a lot about amphibian population biology, so I can't comment in too much detail, but that was a plot device for the movie. It would actually make far more sense to complete it with the bird's DNA. Oh, okay, so this next question that was asked, I've actually already touched on. It's, was the dig shown at the beginning of the film, the unearthing of the Velociraptor skeleton, was it accurate to actual dinosaur excavations? It was okay. Again, in Montana, that's not accurate to the actual Montana soil, but other than that, where you get that kind of soil, the depiction is not that bad. The whole computer program, again, that's a very archaic, very basal computer program, computer radar program, and we have much better technology today. Okay, so I think my math is right. We're at question 12 now. How much did Jurassic Park, the movie, drive interest and funding in paleontology? In funding, it at least what I was told, what we were told in that session was it barely did anything to increase the funding. I don't understand why I'm feeling a little congested now. Maybe it's because I've just been talking for so long. I don't have a cold, so it's kind of weird. Okay, so it barely did anything in the funding. It barely drove it up at all. And these when museums go out on these digs, when scientists and professors look for funding for their lab research, it's government funding. It's applying for grants for scientific research. It's difficult to do. It's difficult to find. Or if you are trying to look for non-government, look for independent funding, again, that's very hard to do. You have to find sponsors. You have to find patrons. John Hammond was the one who was financing the digs in the movie. I'm not sure how John Hammond made his money. He's said to have been working on a lot of large-scale projects. He was talking about the flea circus at some point in the movie that he built. Apparently he's had these other projects, some of which must have been hugely successful. We don't know exactly what they were, but apparently he can fund the building of an entire clone dinosaur park, along with all the genetic research that would be going into that, as well as fund scientific research in other areas. So he must have had some huge success somewhere. Now, in interest in paleontology, the movie sent it not through the roof, but to the stars. Interest in dinosaurs exploded after the Jurassic Park movie. There were children who were in the range of like 6 to 10 years old in the early 90s who have now become full paleontologists because of that movie, because their interest was skyrocketed by that movie, who have their own labs now, who have their own graduate students. I'm trying to get there myself. I was one of those. I was 8 years old when the movie came out, and I became a Velociraptor groupie almost instantly. I'm also trying to work on a lot of modern day ecological issues and answers, so it's not all dinosaurs. I'm trying to work with various branches of science, so I'm kind of a little more all over the place. But it did wonders for interest in paleontology, probably far beyond anyone's expectations before they actually saw it. Question 13. How did avians survive the KT boundary? Okay, so how did dinosaurs that had evolved into birds survive the end Cretaceous extinction event, of which the Chicxulub asteroid was, so to say, the final nail in the coffin for the non-avian dinosaurs? How did the birds make it through? Well, they almost didn't. Birds went through quite a massive species and population bottleneck. They just barely pulled through. And a lot of it, I think, had to do with the fact that, like a lot of mammals at the time, they were very small-bodied. They didn't need very many resources, very much food at all to be able to survive, or at least the ones that did survive. There were some very interesting toothed bird species, some toothed seabirds that did not make it through. Maybe a couple of them did. Many forms of birds, of early birds, did die out. But they were able to cling on enough, the birds, to make it through. They almost didn't. Okay, so question number 14. The word dinosaur comes from demos or dinos, for terror or terrible, and sauros for lizard. Dinosaurs, when they were first widely discovered, were given the name terrible lizard because they were reconstructed inaccurately to be very lizard-like. If you look at the very early depictions of the dinosaurs, Iguanodon and Megalosaurus, they basically resemble Megalania more than anything you'd recognize as a dinosaur. And so they were called terrible lizards because they were thought to be pretty much exactly what Megalania, which came much, much later, was, giant ripper lizards. This, of course, has been found to be an inaccurate depiction in so many ways. So why do we keep the name dinosaur? Why do we keep the name lizard in there? Wouldn't it be more appropriate to rename them as something else? Maybe terror birds. Well, actually, it's a whole other group that has the name of terror birds. Usually it refers to the forest rakids, which also came later, although actually the very first of them appeared not too long after the dinosaurs went extinct. And of course, dinosaurs, not all of them were very close to bird ancestry. That was one unique branch of dinosaurs, so they were not all bird-like, not by any means. As for giving them any other name, I'm not sure what it would be. Maybe terrible beasts would be Dinotherium. I think there's a creature that already has that name, although I don't know what it is offhand. I guess they'd be called Dinotheres. I don't know if that's taken or not. But dinosaur is just too iconic. We've all grown up with it. That's not going to change. And it doesn't really matter that much now. We know they're not lizards. We just keep the name. Question number 15. When did mammals first appear? Well, mammals evolved from a different branch of reptiles than dinosaurs did. And dinosaurs and mammals actually had their origins diverged from other reptile groups. The ancestors of dinosaurs and mammals diverged from other reptile groups actually at about the same time. It's just that by the time of the end Permian, there were actually a lot of even large-bodied mammal-like reptiles. If you've heard that name before, often there's a creature called Dimetrodon, that like finback lizard, that is often included with the dinosaurs. Was not a dinosaur at all. In fact, was a lot more closely related to mammals than to dinosaurs. That lived during the Permian. So that was a predator. There was also an herbivore, finback. Well, there were many species. I'm talking about the most iconic. The herbivore was Edaphosaurus. There was also a very common mammal-like reptile called Listersaurus. There was the saber-toothed, slightly, the sabers were not huge, mammal-like reptile, the Gorgonopsids. Another one called Placerius, which appears in the original Walking with Dinosaurs. I'm not talking about the Pachyrhinosaurus, Gorgosaurus movie. I don't care for that movie much. I'm talking about the original six-parter. The first one takes place during the Triassic, not the Permian, but a lot of the very last mammal-like reptiles appear and are mentioned. And these mammal-like reptiles, these reptiles close to the ancestry of mammals, could have become a dominant group had they not been largely wiped out by the end Permian extinction, which is, since dinosaurs pulled through a little better, or the ancestors of dinosaurs pulled through a little better, they came to be the dominant creatures on Earth for the next 150 million years. And during that 150 million year reign, pretty much almost completely suppressed the evolution of mammals. That's why mammals took so long took until the Cenozoic, took until the dinosaurs disappeared to really take off. but mammals and dinosaurs first appeared at about the same time. Question number 16. What was your favorite part of the movie? I'm sure everyone has a different answer to this one. So Dr. Ryan's answer was the Triceratops. He's a specialist in horned dinosaurs, as was Jack Horner, the paleontologist consultant for Jurassic Park. So they liked the appearance of the Triceratops. Even though we never, and still haven't, gotten to see that iconic in artwork Tyrannosaurus versus Triceratops fight in any of the movies. That's interesting. My favorite part is, of course, the raptors. Anytime the raptors appear, I squee. I mean, come on, I warned you about me. Velociraptor groupie. So, feel free to comment and talk about what your favorite part of the movie was. And the last question. What is the leading theory on what killed the dinosaurs? And I have gone through that already. It was a number of factors during the end of the Cretaceous that all combined together pretty much in the worst combination possible for the dinosaurs to have to live through. And it was different from the end Permian extinction, which was actually a far worse extinction than the end Cretaceous, because at the end Cretaceous extinction killed off about I think it's around 75% of all the species on Earth, of 75% of the biodiversity at the time. At the end of the Permian, 90%. And I've even heard possibility of 95% of species were wiped out. So the early dinosaurs made it through a worse extinction. Now why? Well, it's because that during the Permian, dinosaurs were still very small, had evolved in those arid, those fringe habitats, those environments where they had to survive in small size with very little resources, so they could make it through a time like that, or at least had a much better chance. Not all of them did make it through. But by the time of the Cretaceous, the dinosaurs had been producing their largest species, their most I'm trying to say not just resource dependent, but dependent on ample resources in their habitat. The species like Triceratops and Tyrannosaurus and the large hadrosaurs, who really couldn't survive very well, if at all, in environments that were aridifying, if that's a word, I'm not sure that's used. But you know what I mean. A lot of the volcanic activity had done damage to the environment. Dinosaurs had just been growing larger and larger to try and outcompete each other. And unfortunately, the problem with that is if animals are doing that and hard times hit, they're screwed. And then when you pile the asteroid impact on top of that, well, that's the point of no return. Except for the animals who can survive in the fringe habitats with few resources. Exactly why a lot of the a lot of the aquatic reptiles, which the reptiles grow large, but they have a slower metabolic rate. They can go for very long periods without eating. That helps. And then the small animals who can regulate their body temperature but don't need that many resources. The mammals at the time, the first birds at the time. No, I'm sorry, not the first birds. Birds had been evolving for quite a while. I think the first birds appeared even now. It's been found during the early Jurassic. It used to be the middle or late Jurassic. We found even earlier birds. So they'd been around for a while, but they were still small. All but the largest pterosaurs had died out, so they were facing the exact same problem. A lot of the largest sea creatures too. Crocodiles made it through, but the mosasaurs, which were quite a bit more active, I think, did not. Sometimes in Earth's history, these, even very successful groups of animals, and dinosaurs certainly were, certainly one of the most successful groups of large animals, of macrovertebrates, ever to appear. And their descendants are still with us. Amazing success. Even these very successful groups of animals can hit a point in just environmental conditions stacking against them that they can't recover from. It does happen. Even mammals actually have gone through a couple of mass extinctions, not through the point of no return yet, but there have been many groups of mammals, groups of large mammals that have died out. And I'm not just talking about the Ice Age megafauna. There were many groups that came and went even earlier than that throughout the Cenozoic. The South American terror birds, the forest rakids, had a run of about 62 million years, and somehow only a couple million years ago they disappeared, which in paleontology is often pointed to being outcompeted by mammals when they came down to South America during the Great American Interchange, when that land bridge raised out of the water between North and South America. There are some problems with that hypothesis. And this is actually one of the questions I'd like to look into in paleontology, find out more about what happened to the forest rakids and more about their reign, because they are, while not unknown, they are quite a bit less studied than dinosaurs. They are one group of predatory birds, whereas dinosaurs, of course, had many groups. So they're a smaller collection of creatures, but they too are awesome. In fact, they're pretty much the bird equivalents of Tyrannosaurs and Velociraptors, so very much awesome. Now I could talk a lot more about the Jurassic Park movies, about the science involved, and about paleontology and ecology, and I will, but I think that will do that for tonight. So yeah, comment, subscribe if you want to, tell me what you want to talk about. I'll be doing more videos on the Jurassic Park movies, about dinosaurs, about all of it. I will be talking about those talks I went to about the topics of the Dino Fest that took place on November 12th, 2016. So until then, I am the Velociraptor groupie, and I'll see ya.